Hi, I'm Mr. True. In this video, we're going to continue our discussion of solving equations that have fractional coefficients. We're going to do that in this video with some word problems that deal with work. Not physics work, but cooperative work. And our first example here is pump A can empty a pool in 20 hours, and pump B can empty it in 24 hours. Well, if that's too slow for each of those individually, if they work together, how long should it take to empty the pool? So we're kind of doing like cooperative work problems here. And the fractional part's going to come in to play when we talk about the speed at which these pumps are working, and the fact that the question is asking, how long is it going to take to empty the pool? Well, the question is in terms of hours, and I can't really use the numerical values of 20 and 24 as they stand right now because that's the amount of time it takes to finish the entire job. And together, there, of course, it's going to happen faster. So we're going to figure out or write down how much work each pump gets done in just 1 hour. And that's because that's the unit of measure that's given to us in the problem. And then put those two pumps together and add the amount of work per hour, the percent of work they get done per hour, add those two up, since there's just two pumps, and have it equal 1 or 100%, because they'll be done. 100% of the work will be finished. So pump A is going to be, let's see, in 1 hour, it's going to get, well, it takes 20 hours to get the whole job done. So in 1 hour, it's going to get 1/20th of the work finished. And then in pump B's case, well, with pump B in 1 hour, well, it would take 24 hours to do the whole job if it was working by itself. So that means in 1 hour, it's going to get 1/24th of the work done. Now, we want to know how long does it take for the entire job to be completed? Well, if the entire job is going to be completed, then 100% of the work will be done. And 100% in terms of a decimal is 1. You move that decimal back 2 places and you get 100% as a decimal is just simply equal to 1. So our equation for this problem is going to be, okay, we have pump A and pump B working together, and these are the speeds at which they work per hour. So we're going to have 1/20th x plus 1/24th x equals 1. And I just realized I didn't define the variable x, so let's put this down here. X is going to be equal to the number of hours it takes to finish the job. You should always define your variable when you're doing a word problem. So in 1 hour, pump A, 1/20th of the job, pump B, 1/24th of the job. They're going to work together, and after a certain number of hours, they're going to get 100% of the job done. That's where the 1 comes from. So, like I did in my video where we just worked with the equations, we want to multiply, just for convenience sakes, we're going to multiply both sides of the equation by a number that's going to cancel out both of the denominators. Well, this is 4 times 5, and this is 4 times 6. So if I take a number that has a factor of 4, a common factor between 20 and 24, a factor of 5 and a factor of 6 together, my lowest common multiple, I can put that through, keep my numbers as small as possible, and get rid of the denominator. So 4 times 5 is equal to 20, and the 24 already has a factor of 4, I just need to add a 6, so 20 times 6 is 120. So we're going to multiply both sides of the equation by 120. Distribute that through, and we're going to get 120 over 20x plus 120 over 24x equals 120. And I'm just showing that for teaching purposes. We need to actually, the purpose of that was to cancel out the fractions. So let's see, 120 divided by 20. Well, the zeros are going to cancel out, and 12 divided by 2 is equal to 6. And 120 divided by 24, let's see here. Let's see, how about 5? 5 times 20 is 100, and 5 times 4 is 20. So yes, this does cancel out to be 5x. So we're going to add like terms now. 6x plus 5x is 11x. We're going to divide both sides by 11, and we're going to get x is equal to 120 over 11, or approximately equal to 10.9 hours. So, pump A, 20 hours alone. Pump B, 24 hours alone. If they're working together, the whole job is going to get done in 10.9 hours. If you want to make sure that this is actually the correct answer, you want to take this 10.9 or the 120 over 11, plug that back into x and do 1/20th times 10.9 plus 1/24th times 10.9, and make sure that you get an answer very close to 1. If you do the exact value of 120 over 11, you will get the answer of exactly 1 if you want to check your work and make sure you're right. This might be just very close to 1 due to some round-off error. Got one more example for you. Bam! Second example, and last one of the video. A painter can paint a building in 15 days, and a co-worker can do the same job in 10 days. So hopefully he's getting paid more. If the first painter starts in 3 days later, the co-worker joins in to help finish the job. How many days does it take to paint the entire building? Well, again, we're going to focus on the rate at which the work can be completed. And since this unit of time is in days, see, we'll do the first, that second guy in blue, and the first painter in yellow. The unit of measure is days. So we're going to figure out how much work gets done in each individual day, what fraction of work, fractional coefficients, which is the same as a percent, part over whole. What percent of the job are they finishing per day? We're going to add their work together and set it equal to 1, representing that 100% of the job being finished. So painter, let's call him painter A, is going to finish 1/15th of the work per day. Painter B is therefore going to be 1/10 of the work per day. And then we're going to, once again, identify the variable x as the number of hours worked. Or, excuse me, not hours, but days. Okay, so painter A starts the job, this lower guy. So he comes in, or she comes in, and we have 1/15th x. So the work gets started every day, 1/15th of the job being done, and then 3 days later, the second worker comes in and joins the crew. Doesn't replace the first painter, but joins in. So they start working together. So that's going to be 1/10. Now, what is that going to get multiplied by, though? Because remember that x is the number of days worked. Now, one painter, we don't know a clue. We have no idea how many days that painter worked. The first person that started, they're on the job every single day. And however many days the job takes is how long they're there. But we do know something about the second painter. They come in 3 days later. So while x is the number of days that the job takes, really it's the number of days it takes the first painter on the job, the number of days that painter is on the job. The second painter is there for 3 days left, right here, 3 days later. So we're not going to stick another x next to this fraction of 1/10, but it's going to be the number of days that the entire job takes minus the 3 because they came in 3 days later. Then together that equals, 100% of the job done. When is the job done? 100% of the work. This percent gets done by the first painter every day. This percent of the work gets done every day for the second painter, and then they're going to work together to get 100% of the job done. Well, like the last question, we want to multiply by something that's going to cancel out the denominators, and between 15 and 10, that's going to be 30. So we're going to multiply both sides of the equation by 30. and 30 divided by 15 is 2, so that's going to be 2x. And 30 divided by 10 is going to be equal to 3, so we have plus 3 times x minus 3 equals 30. I did not take the 30 and distribute it into or inside the parentheses. I didn't distribute the 30 to the x and the 3 because, well, it's in parentheses. This is one term. It's 1/10 times x minus 3, and the parentheses are locking all that together. So there is only two terms inside these blue parentheses, so only multiply by 30 twice. Now we're going to once again distribute it through those parentheses, and we have 2x plus 3x minus 9 equals 30. That's going to be 5x minus 9 is equal to 30. We're going to add 9 to both sides, add 9 to the left, add 9 to the right, and get 5x is equal to 39. Divide both sides by 5, and x is going to become, let's see here, how many 5s are in 39? 5 times 7 is 35, and the difference left is only 4, so we can't put another 5 into there. So 7 times 5 is 35, with the remainder of 4, so it's 7 4/5 days. So the first painter is there for 7 4/5 day, and the second painter coming in that came in 3 days later is only going to be there for 4 4/5 days. And if you want to make sure that this is the correct answer, of course we do need to have a correct setup to start the problem to begin with, but we can take the 7 4/5, plug it in everywhere there's an x, and work this out. And when you distribute and combine like terms and do all the arithmetic, you should of course get an answer of 1, that 1 equals 1. And that is my last example, and that means I'm done. Now you go do your homework.